Hello, my dear students. Welcome back all over again. I'm your maths teacher, Teacher TrSurekhaNilesh, continuing with chapter number 3, Arithmetic Progression. I hope you all are doing fine. Now let's see the next part of this lesson. Johann Friedrich Karl Gauss. He was a great mathematician. At the age of 10, he discovered a shortcut method to calculate from 1 to 100. He was the only child in the class who did it correctly. Carl Gauss was a great mathematician. He was from Germany. He was born in Germany. He was the only son of uneducated parents. He published a book with his friend on algebra. Let's see how he did such a great thing.
At this point, since we're only dealing with basic arithmetic, we've limited our patterns to just those that appear with multiplication and addition. These simple patterns and harmonies in arithmetic are only a small sample of what is out there in the vast sea of numbers. These patterns are what make math work. What's more important than memorizing any specific pattern we've seen is knowing that such patterns exist and having a mind open to seeing them. The ability to see these patterns is an important skill in mathematics, and ultimately, being able to use math to understand the world around you. A great example of someone who was able to see the mathematical patterns around him is Carl Friedrich Gauss. In 1787, young Carl was a 10-year-old student in Braunschweig, Germany. The pattern that was perhaps most apparent in his class was the tedious repetition of a dismal life, toiling over slates in a drab, low-ceiling classroom and avoiding beatings from the abusive teachers. There was an instructor at the school by the name of Büttner. Although he enjoyed intimidating his students, Büttner often found that teaching involved too much work. He therefore devised ways to keep his students busy for hours on end while he sat back to relax. On one occasion, as the story goes, he gave his class the task of adding together all the numbers from 1 through 100. This, he had hoped, would earn him a relaxing afternoon of watching students tap away at their slates. He had barely finished his instructions when his student, the young Carl Friedrich Gauss, stood up from his desk, walked up to the front of the room, and turned in his slate on Büttner's large desk with an offhanded, "There you go." Young Carl sat quietly for the rest of the afternoon as his fellow students finished their addition, and Büttner planned how he would beat his arrogant student for avoiding his classwork. One by one, the other students finished and placed their slates on top of Carl's. When all of the slates were turned in, Büttner immediately ripped Carl's slate out from the bottom and looked at it. To his astonishment, he found that Carl had the correct answer, and the only number on his slate was the answer. He had written no calculations whatsoever. How did he do it? How had he figured out how to avoid such boring, repetitive work and still produce the correct answer? Let's see if we can start to find a pattern.
So students, the story was quite interesting. Now let's see how he did.
The crowd is absolutely electric at the 1787 World Math Championship. The defending champion teacher is up by 1 point as we head into the final question, but young up-and-coming 10-year-old Gauss has been having a monster game. You couldn't have scripted it any better than this. The teacher has selected a 10-point question of maximum difficulty. What is the sum of the whole numbers from 1 to 100? This is an incredibly hard question. I don't know how Gauss is going to figure it out. He is going to be working against the clock. He's added the first 4 numbers and gotten to 10. But he realizes this won't work. He has to start over and think more creatively. He's back to the drawing board and he writes out the problem. But I don't know how he's going to figure it out. He's now writing the expression in reverse, and it looks like he's going backwards because I can't see how this could possibly help him. What's this? He's now adding up the 2 expressions, and oh my gosh! Every single column sums up to 101. I have never seen a pattern like this before. Gauss has figured out something that is going to shock the world. 2 times the sum is equal to 101 times 100 because there are 100 terms. He now figures out the sum by splitting the product in half. And so the sum is 101 times 50, which is 5,050. Gauss has figured out the answer, and he has plenty of time to spare to check his answer.
So students, that was quite incredible thing done by Carl Gauss at such a small age. The sum of first n terms of an AP. Arithmetic progression: A plus D, A plus 2D, A plus 3D, and so on till the nth term, that is A plus n minus 1 times D. In this progression, A is the first term and D is the common difference. Let's write the sum of the first n terms as Sn. So Sn equal to A plus D, and it goes on till A plus n minus 2 times D plus A plus n minus 1 times D. Now the above whole equation, we will be reversing and rewriting the expression again. So Sn equal to A plus n minus 1 D plus A plus n minus 2 D plus A plus D plus A. On adding, we get 2Sn plus 2Sn equal to A plus n minus 1 times D plus A plus D plus A plus n minus 2 times D, and so on till A plus n minus 2 times D plus A plus D plus A plus n minus 1 times D plus A. So we get 2Sn equal to 2A plus n minus 1 times D plus 2A n minus 1 times D plus 2A plus n minus 1 times D, and so on n times. So we get 2Sn equal to n 2A plus n minus 1 times D. Dividing both sides by 2, we get Sn equal to n upon 2 2A plus n minus 1 times D, or we can say Sn equal to Na plus n minus 1 upon 2 times D. Let's remember, for the given arithmetic progression, if the first term is A and the common difference is D, then Tn equal to A plus n minus 1 times D, and sum of the first n terms of AP, that is Sn equal to n upon 2 2A plus n minus 1 times D equal to Na plus n minus 1 upon 2 times D. Let's find one more formula for the sum of the first n terms. In the AP, A plus D, A plus 2D, A plus 3D equal and so on, a plus n minus 1d. The first term t1a and nth term is a plus n minus 1 times d. Now the sum of the first n terms of AP, that is Sn, equal to n upon 2 a plus n minus 1d. So we get Sn equal to n upon 2. A is the first term and the whole part, the next part which is underlined, that is a plus n minus 1 times d, that is Tn, equal to n upon 2, that is first term plus the last term. Now to understand it more clearly, let's see a video.
How do we calculate the sum of terms? Look at the set of numbers 2, 3, 7 and 6. How do you find the sum of the numbers in this set? You simply add the numbers, right? And 5 plus 13 gives us 18. But this method gets difficult for larger sets. Say we have a set like this one, and we have been asked to calculate the sum. We cannot just add all the numbers. It is not the best way. Look at the set again. Do you see a pattern? Yes, the numbers in this set are evenly spaced with the fixed interval being 4. But how does that help us get the sum? We know the general formula for the arithmetic mean. It equals the sum of terms divided by the number of terms. Okay, and do you recall what we covered in the previous videos? We know the formula for arithmetic mean of evenly spaced numbers. And we also know the formula for finding the number of terms of such sets. If we know those two, we can easily find the sum. Let's separate this example first. Juggling the terms, the sum can be written as arithmetic mean times the number of terms. The arithmetic mean for evenly spaced numbers is first term plus the last term divided by 2. And the number of terms of an evenly spaced number set is last term minus first term divided by the increment plus 1. We know that the fixed increment is 4, so all we have to deal with is the first term and the last term. First term plus last term is 32, so the arithmetic mean would be 32 by 2. And last term minus first term is 28. So the number of terms will be 28 divided by 4 plus 1. This is 16 and this will be 7 plus 1, 8. It gives us 16 times 8, which equals 128. The sum of these terms is 128. I'm sure the thought of directly adding up all these numbers has crossed your mind. Much better than using these formulae, right? What if I tell you that the series went up to 202, 34, 38, and so on up to 202? Now tell me, which method would you choose?
So students, this was quite interesting. I hope you understood it. I hope you understood the concept of finding the sum of n terms of an AP. Now find the sum of all odd numbers from 1 to 50. This is an example. Odd numbers from 1 to 150 are, please do the correction in the question. It is find the sum of all odd numbers from 1 to 150. So the odd numbers from 1 to 150 are 1, 3, 5, 7 and so on till 149. It is an odd number. Here the difference between any two consecutive terms is 2. That is 3 minus 1 is 2, 5 minus 3 is 2, 7 minus 5 is 2 and so on. So it is an AP. Here the first term, that is T1, is 1, that is A equals 1 and the difference between them is 2, that is D equals 2. Let us find how many odd numbers are there from 1 to 150. That is, find the value of n. So our Tn is 149. We need to find the number of terms. So we will write the formula Tn equal to A plus n minus 1 times D. We will substitute the values. Therefore, 149 equal to 1 plus n minus 1 times 2. Therefore, 149 minus 1 equal to n minus 1 times 2. We have subtracted 1 on both sides of equation. Now we will be dividing by 2 on both sides of the equation. So we get 148 upon 2 equal to n minus 1. So that will give us 74 equal to n minus 1. Adding 1 on both sides of the equation, we get n equal to 74 plus 1 equal to 75. So we got the nth term over here. Now let's find. Now let's find the sum of 75 numbers, that is 1 plus 3 plus 5 plus 7 and so on till 149. Here you can use the first method or the second method, whichever is convenient to you students. Method 1, here A equal to 1, D equal to 2, N equal to 75. Writing the formula Sn equal to n upon 2, opening of the square bracket, 2a plus n minus 1 times d, closing of the square bracket, substituting the values S75 equal to 75 upon 2, opening of the square bracket, 2 into 1 plus 75 minus 1 times 2, closing of the square bracket. Solving the square bracket, we get 2 ones are 2 plus 75 minus 1, 74 and into 2. 75 upon 2 into 2 plus 74 into 2. When we multiply 74 by 2, we get 148. Adding 148 by 2, we get 150. Now 75 upon 2 into 150. Dividing 150 by 2, we get 75. Therefore, 75 into 75, we will get 5625. So, S75 equal to 5625. Method 2. Here T1 equal to A equals 1, Tn equal to 149, N equal to 75. Sn equal to n upon 2 into T1 plus Tn. Substituting the values, S75 equal to 75 upon 2 into 1 plus 149. 1 plus 149 is equal to 150. That means 75 upon 2 into 150. Dividing 150 by 2, we get 75. 75 into 75, we will get 5625. So, S75 is 5625. Thank you, my dear students. I hope you understood the concept of the sum of the first n terms of an AP. Stay blessed, stay safe.